Find out soon. Okay, let's give it a few minutes to work with it. Okay, soon. Okay, and we're up. Fantastic. Okay. Okay. And we're up. Fantastic. Okay. Okay. And we're up. Fantastic. Okay. Okay, so I'm going to mute that because I don't really need that. As long as I know that's working, we are basically good to go, more or less. I will, however, keep it up because I want to see the chat. That's about it, though. Every now and again. Okay, I'm also going to drop into the voice chat in Discord, so we're good there. Okay, that should work there, I think. It's always messy getting this many audio devices to play together, so I'm just going to make sure that one actually comes. I can't until someone else joins. That's fine. We'll see how we go. So we are going to just clear things up a bit so we can get ready for this as we go. Okie doke. Thanks, son. Okay. But yeah, we're basically ready to go. Just welcome, Shane. How's it going?
Good. How are you guys getting on?
Pretty good, pretty good. Okay, so you're probably the only one here at the moment. That's cool. You ready to get going? I know you said you were pretty tired this morning, so...
I'm always tired, so you can ignore that.
That's definitely a feeling I understand. Okay. Oh lord, let's get out of that screen. That's gonna be messy. Okay, so... are you on the stream as well?
Nope.
Let me go ahead and grab a VS Code share link for you real quick. Alright, live share. Okay, that's fine. Just need that. Okay, what do you mean? Select both times. Alright. Yes, Windows, this is fine. Don't need that right now. Just want to go ahead and get a copy link. Perfect. Okay, so I'm actually just going to drop this in the streaming channel for you. And if anyone else wants to join, they can join too. Okay, so that should... Yep, okay, so that should work out. It's usually pretty straightforward. Famous last words, though.
That makes sense. Got me on my... Yeah. Okay, now we're getting somewhere. Yep, it's installing now, and I should be good to go.
Awesome sauce. Okie doke. What's this? That's my log. Okay. This is happening. I'm just gonna double check. I'm getting. Okay, that should be fine. Cool. Okie doke. And yeah, we're set here. Coolo. Alright. Just give me a holler once you get in, we'll get started.
Will do. Let's see if I can figure out how to get this onto my headphones and not the speakers.
Okay. I'm gonna put a link in here as well. Okey-doke. There we go. And yeah, that's about all the setup I can really manage at this point in time. Hi Corbob, what's going on? He doesn't look very enthused in the chat, but that's fine. He'll be fine. The trouble with... What is the light mode say? Sorry, Corbob, it's just easier to see? I don't know. You can deal for now, I'm sure. It'll be fine. Sounds good, hun.
This is great because I can see your Twitch, but the live share is just not working for me.
What's going on?
Well, to be honest, I think this laptop is like 7 years old.
Oh lord, okay. That's fair. I mean, we can go with it just over the stream, but you're gonna get double voice, so it's gonna be a bit confusing, I'm sure.
It's actually working out because I got the I've got the Twitch muted, so
Okay.
I'll be able to Discord.
Alright, well yeah, if you wanna follow on, that's really chill. So alright, so basically what I'm gonna try and cover, because I know there's quite a lot in this file. This file is, how many lines is this file? This file is what are we looking at? 4,700 lines, so it's a bit of a big file. So we're gonna have to skip over some things, but basically this is the code that PowerShell uses to translate raw text into script by essentially breaking it down into individual tokens. Like there's a token for each individual keyword, each operator, each, I mean, even a number is a specific type of token. So basically this tokenizer, as they call it, is PowerShell's language lexer. It turns raw text into its little units of language. As I said, this file's giant, so we're gonna skip a couple things here. And I know the stream's like a little behind, so you might be a little confused here for a sec, Shane, but that's totally fine. We'll figure it out as we go, I'm sure.
Thank you for saying for a sec, not the whole stream.
What was that?
Thank you for saying I'll be confused for a second and not confused for the whole stream.
That's fair. I will admit this file isn't the easiest to work with anyway, but it's fun. So alright, we're gonna skip ahead a little bit here because this is all behind the scenes stuff. This is what they use for a bunch of different keywords, and we're not gonna get into that right now because that is, as you can see as I slowly scroll by, kind of a bit of a mess. It's not terrible, and it does work very well, but that's something you want to get into if you want to work with any of the inbuilt language keywords, which are not easy to work with, honestly, but they do work very well. It's would be a bit of an extra deep dive even beyond this, I think. But let's see, this is all dynamic keyword stuff. I'm just going to skip this. We'll start here. So basically, the tokenizer has 4 different modes, basically. Most people only really are vaguely aware of like 2 or 3, whatever. But basically it has your command mode, which is you enter native commands or commandlets or just anything that's like a bare string command will be parsed in command mode. It also has expression mode, which is for like math and things like that. Any kind of expression with operators, strings, raw values. And it has as well. It also has a type name mode. Obviously when you're entering, type names like string or int or list or whatever you're working with and the data types. And then it has a signature mode, which is specifically for class and method declarations. And once again, that is a very, very fun little topic because those things are, from what I hear from the PowerShell team, a bit of a nightmare to work with because it's essentially half the time they're trying to convince the C# JIT compiler that yeah, this is actual like usable code once they translate it over. I haven't delved in there very much, but it doesn't sound particularly easy to work with. But yeah, so we're gonna skip over that a little bit. We will come back to that, but for the moment, it's just the 4 different modes. It's simple enum. It just basically keeps a list of what modes you can have, and that's probably going to stay that way for all of time, probably, unless they figure out another way to work with things. And of course, Shane, feel free to interrupt me with questions, whatever you have as we go. I'm more than open to it. Because I could talk about this forever, but I'm sure that'll get boring. So if you want to jump in at any point, just feel free. So what we're looking at here is the number of suffix flags. This is something I actually added myself. So initially when this was designed, I'm not sure if the initial suffixes like L for long and D for decimal were in there from V1, but I think they were definitely in there from V2 of PowerShell. So before I put this stuff in for the extra things like signed bytes and shorts and all sorts of extra number types, and as you can see, I've got them all pretty well documented here, so it's pretty clear like what's what. They basically just stored it as a string value, and it was a little bit tricky to deal with. Like you were always like, oh, is this specific character, and which is fine as long as you only have a couple to deal with. As soon as you get to like a couple, or there's like ones where I added like you can add multiple letters to suffix it to define the data type, that just didn't work. So I put this little enum in, and it might be getting expanded at some point later. We'll see how we go. There's a PR that's still being worked on for this one, and a few other things as well. But yeah, so this here, then we'll move on to actually functionality stuff. This is the tokenizer state internal class, I guess, basically. So what this does is whenever you have a script block in your script, it as soon as it hits that, it'll store the current state in an instance of this class. There we go, I can accept that, maybe that'll work. And once it's stored it, it'll then basically just wipe itself to a blank slate, because this is all it really needs to keep for it to continue after the script block. But every instance of a script block is like a completely new instance of the tokenizer itself. It just resets, goes from beginning to end of the script block, and then uses this tokenizer state class to jump back to where it was before and continue going on with the script. So that's kind of how it handles nested scans on the same string. So if you have to scan anything with nested code, nested script block, stuff like that, it's basically just how it handles it without going completely crazy. It'll keep it'll keep some tokens here. It'll keep the actual string script. All of the actual script you're working with here is actually just stored as strings and characters, because this is the very basic, bare bones, bare metal, I guess you could say. But yeah, so it'll keep all this information, and it'll pull it back to its own properties when it needs it. This is the actual tokenizer class here. I'm not going to try and explain literally everything, because honestly, it does get kind of crazy. I'm not going to lie. But essentially, it will keep a list of keywords, list of operators, a list of invalid characters, which isn't very many. It just has one, which is just the highest value of a character is what it uses for an invalid character. I couldn't tell you exactly what that's used for, but we could check it out if we felt like it. And VS Live Share actually helps us out here. Okay, so it uses a surrogate in certain places, or if it's okay, so if it's basically gets the invalid input, it just returns this invalid character. Nice. And then it's, you know, other little statics here, which are how many hex digits you can use in a Unicode escape string. It keeps an instance of the parser class in itself, which is basically what PowerShell uses to turn these tokens into actual into the actual AST, the abstract syntax tree. And I'm getting a bit of an echo there, so just double check. Is my audio okay? Have I got Shane? You might have an extra audio there somewhere.
It would not surprise me.
Alright.
I'm gonna close Twitch because I got laptop working now.
Okay. Okay, so where are we here? So we've got. I'm gonna actually. Are you in the live share now?
Yeah, I'm in the live share.
Hell yeah. Okay. Let me see if I can pull you down here so you can follow along a bit. Okay. So these things. It's easier to kind of show you where they're used than explain them all, because honestly we could spend hours explaining all these and never get to what actually happens. So I'm going to skip ahead a little bit here. Basically this is what stores the actual script file. When you read in and PowerShell needs to pass it, it will store the entire script as a string and just step through it one character at a time, basically. Okay, so we got token structure and then index. This is just how it keeps track of where it's at. And then let's go down a little further here, and we're looking at the initial keywords. So this is basically it just keeps a one-to-one mapping of what a keyword string is and what the actual defined token type is for it, or token kind as it calls them. This is pretty straightforward. You know, like everything just maps one-to-one to its token kind, so it can figure out which keywords are which pretty quickly. Those are, yeah. Same with operators. You'll notice the operator strings actually don't have the dash that all the PowerShell operators actually have. That's because the dash is basically what it uses to tell, oh, there's probably an operator here. Look for an operator. If it finds one, it doesn't even need to worry about the dash actually being there. But of course, it stores it in the actual text that it stores in the script. So it's just a little behind-the-scenes implementation stuff there. Everything just maps one-to-one with what it is. This is all the predefined. We know exactly what this stuff's going to be. We can just look it up and grab it real easily. So
I don't know what SHR and SHL is, though.
What was that?
I don't know what SHR and SHL is.
Those are shift left and shift right, the binary operators. So I don't know if you've done any binary stuff in C# or anything like that, but
No.
just bitwise shifting, yeah. I mean, yeah, there's a whole bunch, honestly. And they actually have separate token kinds for the case-sensitive ones as well, which is interesting, but, you know. Okay, so here is just your basic constructor. You got some assertions. You'll actually probably never see these pop up in an actual build of PowerShell. These are only used in debug builds. So if something goes completely wrong on a debug build, you can usually know straight away, because it'll trip and assert. And if something like this fails, you will know about it. You usually get like a stack trace or something like that. It's not very pretty, but it tells you that something's very wrong. Had a couple of those myself. Working with the tokenizer is very interesting. If you mess it up too badly, it just kind of stops working completely. So that's always fun. Okay, we're going to skip a little bit here because this is all just predefined stuff, and they're relatively self-explanatory once they're actually in context. But like, you know, the first token, last token, and then all sorts of fun stuff. If I had to guess, I would say that's used for the requires statements at the top of a file. And there's a whole bunch of stuff. It just has, you know, is it in this mode or whatever. And you got an initialize function, which basically just is what it uses to set itself to a blank slate. So it will take a file name and input. So basically it takes the string file name and the string input, and it works with it. And then basically the script is set to the value of the input, because that's just your string. And you it does set itself to a token list, which you can pass in if you have pre-existing known tokens for that. But I think you can pass it in as a null, because it usually, or just like as a blank list. I think it's usually passed in, and then that list is read out again after this method is called. So you have your first, last, and it requires tokens, and then it just sets basically everything relatively blank, and you get started. Checks the first character. If it's a return, you check for new lines, and you just start putting stuff together. This is very, very like if it's like blank space at the beginning of your script, basically. Okay, current index here. Yep, and it looks like it just pretty much skips it most of the time. Okay. And then your nested scan stuff. I'm going to actually go scroll down a little bit here, and here's one of the actual base functions that it uses. Pretty simple. It's just a helper function that skips the current index forward one character and then gives you back what that next character is. And then it has a little extra protection in here just in case you ask it for the next character when there isn't one. It will just give you a null character, signifying the end of the script. And there's plenty of things that check for this. And it's like, oh, are we done already? Cool. Unget isn't used that much. It's kind of a weird concept, but some things when you reach a certain point in the script, you actually need to step back one or two characters and figure out what's going on. So that's what this one is used for. It just sets the index back. No real check needed. Although it will check to make sure that you haven't gone back before the start of the script. And then you have a P character, which is, I think, one of the primary ones used here. Basically, instead of so get character actually skips it forward one and then gives you that character. P character instead just gives you the next character. And then I think, does it actually? Yeah. So if it's it just gives you the current character that it's on. It doesn't actually move the index at all. And then you can skip character. Often you'll find peek and skip used in conjunction, so you'll check the next character. If it's what you expect, then you'll skip to the next one because you've already got it. And if it's not what you expect, you will go to some other case or something like that. It just saves a lot of calling get and then unget. And so yeah, it's just preempted basically. It's a lot more common. Like you got 68 references to peek, and I think get probably has a fewer, I would guess. Yeah, like 40. So it's still pretty even, but yeah. And then you've got it's a thing that just checks if you're at the end of file. It just pretty simple. Are we past the end of the script? These are all helper functions. You'll do very simple stuff, and then here's what it uses to determine if a given string is actually a keyword. It just literally checks if this contains that keyword, and then it also checks dynamic keywords as well, which I think are things like using namespace and switch with wildcard, stuff like that, because those aren't technically operators or even really parameters. I'm pretty sure they're dynamic keywords that I have to check to be sure. And then you've got your skip new lines, which essentially does what it says on the tin. It'll skip new lines and white space until it finds more actual script to look at, which is, tabs. I can't remember what /f is. Whatever it is. But basically, these are all white space characters. No breaking space, new lines, stuff like that. And you got semicolons as well. It has an optional to skip semicolons in some modes, which it will at times. And I think those are usually used for sub-expressions when you have the dollar brackets that usually skip semicolons when it's looking for new lines, because they're break lines, but they're not technically new lines in there, I don't think. And stuff like that, comments, and it'll check for block comments. And you'll notice there's a lot of use of helper functions here. So when it reaches this, it just goes, oh, we'll scan the line comment, because it's a lot easier to bury stuff in helper functions than have everything all in point here. If I go, can I go and where's let's peek definition here, and this basically, so you've got line comment, and you just have two booleans defined here, and then it calls another helper function. There's a lot of nested helper functions here, so often you will end up digging a little deeper to figure out what's going on. We're not going to deal with comments today because it's boring. But so you got backticks. Alright, where are we? And you got skip white space explicitly as well. Something I do want to branch out here quickly for is in this skip white space. I don't know if you're actually following along in the VS Live show on the stream, Shane. So
I'm on both, but just for the chat and the stream.
okay, fair enough. Fair enough. Let me.
But like, if you're getting feedback, let me know and I'll kick off.
Yeah, no, you're totally good. I think. Can I? Where is it? No, I can't remember how to do it. That's fine. But so we've got the skip white space here, which actually you'll see its check is literally it checks the character, and there's an extension method called isWhitespace, because I guess that they figure that's easier. Because what they actually have is if we skip over a file here, can I? Yep. We actually have this character traits file, which keeps a master list of what every character that PowerShell uses is going to be parsed as, what it's going to be treated like, and how it deals with it. And it has a list of special characters that it works with. Most of these quotes and things like that are actually just kind of silently converted to regular ones in PowerShell script. There are some cases that are not. It's a bit funky, but it works pretty well most of the time. And then you have this giant flags enum, which is character traits. So it's either you have there's a fair few that are none, but there's a bunch where you've got like a multiplier start for things like the numeric multipliers like kilobyte, gigabyte, megabyte. Those are all dealt with multiplier start. Those G and K and all that stuff have that trait. And you've got type suffix, which I think was already in here, but I've reused a bunch of times for the extra suffixes that I added a while back for the byte suffix and stuff like that. And then we got so like new lines if it's a hex digit, if it's just a regular digit. I have a current PR which is going to add another one in here for binary digits, stuff like that. You know, and there's things that'll force start new tokens. Basically, this is just anything the tokenizer needs to know about that might be a valid trait for it. So, and then it actually goes through, and it has a giant list indexed basically by order of the actual character value. So they can literally index into this by passing it a character value, which gets just converted to an integer and looks it up directly from this table. You'll notice a lot of them are none because they're nothing special. It's like we don't need it, or it will be parsed normally anyway. We don't really need to check what the actual traits are. Most of these are none because they're control characters. It doesn't treat them specially, basically. And then you've got things like white space. Anything with force start new token is things that will basically split up any other tokens. Like it'll split a variable. It'll split like a command name. It's not really a statement break, but it will force the parser to look for another token after it. Then you got blank white space. Here's your special characters, and you can see all these are annotated by their actual character because you would not want to look this up by index. By reading it, it would just be painful. So you got your basic digits, hex digits. I think actually hex digits are down here as well, right? Yeah, hex digits. There's ones listed as type suffixes, so your decimal, your I think I used U for byte, so because that's what F# uses, I think. And so we've got a few of those here. This is just a big list. If you ever want to know what a character would be treated as in the parser, just come here and check it out, because they're all here. This is in the system management automation under the engine, under the parser folder. You can see the parse up here as well, of course. And so we've got a bunch of different characters, and then you have all these extension methods that it adds. So basically, if the tokenizer wants to check a character and see if it is something specifically, it just calls one of these methods rather than checking the actual flag itself. It's just easier, and it just looks better. It's easy to read for sure. So you'll have things like, is this white space? Is this any kind of dash? Because it does have to actually deal with those, because word processors are interesting and painful, but it manages to deal mostly with them. And you have single quotes, because of course there's multiple single quotes, double quotes, all that sort of stuff. Now the is variable start, I think, is mainly it's just your $sign, isn't it? I think so. Let me see. Can I figure, where are we? Sorry, where'd it go? Variable start is dash single quote double quote. This one. I want to see this one, var name first. Let's just check this. Oh, okay, yeah. So there are only certain characters which can be used after the $sign to make a variable. Can't remember offhand exactly which ones, but obviously it's letters, and there's a couple special characters they allow as well for special variables, or underscore, of course, things like that. And then you have identifiers, so labels, and I think that also is command names, but I can't be sure because I haven't worked too deeply in that. But yeah, this is all just your help methods. Is this the decimal? Is this hex? Pretty self-explanatory most of the time. Some of them you'll be like, what is that for? But in context, it usually makes sense. Usually. But yeah, there's a whole bunch of these. So we're going to skip back to tokenizer. Where were we at? We were at the skip white space. And this is, yeah, so this is, I'm going to skip over that because I don't remember exactly what that is. But I think that one is one of the ones it uses with nested scanning. It's been a while. But yeah, so you have the resync one here. Basically, if it hits an error state, and there's an error on a line, it doesn't want to register the entire rest of the script as an error, so it calls this function, and then basically, yeah, rescans from the beginning. So it knows. Hey.
That's the resync function, is it?
Yeah.
Yeah. Okay.
Yeah, there's a couple of them. It takes a token, and then it also takes just an integer start. So if there's, yeah, like if there's a passing error on a line, it'll go, okay, there's an error here, we'll record that, we'll send it back, and then we'll just keep parsing as normal, if we can. Let's keep going, and blistering resync. Right, yeah, so this is if it gets partway through a line and it has like a bunch of tokens already, and it needs to discard them because it's just an error, it's not usable. Replace save tokens, scan new line. Yeah, there's a whole bunch of helper functions. This is all different error functions that it calls, which basically just calls back to the parser to report the error based on whatever overload. I'm not going to go into that because that parser is, I want to say like 13k lines. It's kind of crazy. Isn't character 7 a bell? It might be. I don't remember. I don't remember Core Bob. I'm sorry. I don't know what the cowbells are. Okay. Are you able to turn your mic up at all, Shane? Because I'm having trouble hearing you. Sorry, man.
I think you just called him Corbell.
Oh, yeah. Yeah. So, where are we at? So, current extent, script extents. Okay, so yeah, this is where it keeps track of the full extent of the token that it's currently capturing. Because each token, when it's put into the abstract syntax tree, also stores the actual string that it parsed, which just kind of helps it keep track of things. Okay, so we can get the script extent for a certain. Come on, VS Code, you're kind of slowing down me here. I guess my computer's struggling. Whatever, who cares? And you get comment tokens, and then it can save tokens here for. Come here. It'll save new lines, line continuations, comments. Basically, it just ignores them. We don't need those. Who cares? But anything else, it'll save for whatever it's using here. What is this for? For special variables? Okay, yeah. Got you. So this is for where it deals with special variables for, you know, the $$ and $carry or whatever the hell that thing's called. Because they're not technically actual valid variable names, it just kind of pretends they are because it's handy to have variable names that no one can override. Yeah, questionable, but it works very well. And you have your new tokens, your new number tokens. This is what it just calls to call the proper overloads of save token, and it just helps with the self-documentation of it, because a lot of this stuff gets so complicated you don't want to have like 4 or 5 lines to put the token together, then save it, then figure out which kind of overload you want to use. You just want to, I just want a number token. That's all I want. It's just a lot easier for them to work with, I am sure, because I've had to work with that, and having to deal with the save token would just be messy. But as you can see, there's a lot of like stuff that just passes it and just passes it along down the chain to basically help it actually still be readable, because a lot of lexes are not readable. Putting it regex, because it's just an absolute pain. But yeah, no, you got a bunch of stuff here that these are all helper functions that really, it will use, but it doesn't really make a lot of sense trying to explain them out of context, because this is just what it calls when it finds something that it knows is, you know, a line comment. Skip it. Okay. Block comment. Skip it. That sort of stuff. Backtick will actually check the next character, see what it actually is, and give you proper escaped characters for these things. So, you know, B, A, E for the actual console escape sequence. And then, you know, Unicode, stuff like that. It actually calls a helper one here to grab the Unicode character for whatever the heck you've decided to put in there, which is listed here. This is just how it pulls that one in. There's so much. This is probably the most dense place that I've seen thus far in the PowerShell code, where you have so much report error, like diagnostics assert stuff. It's just like, if anything goes wrong here, we need to know instantly. And it works very well because I have broken it, and yeah, it actually breaks really spectacularly. I did one where I think I misclassified the character traits, because it's just an enum, but it's a flags one. So I put it in without the Unicode prefix on the number, so it was like 10,000 instead of 0x 10,000. So it was registering a lot of things as a binary digit that it shouldn't. It just didn't work at all. It was very messy. It took me a while to figure that one out, actually, because it wasn't strictly an error state, like it was parsing it properly, but it shouldn't have been. It's like, okay.
Yeah.
And you have it actually pulls things from UTF-32 if it needs to. I don't actually know where that's used. I would assume if the script is actually UTF-32, it will call this, but I don't know. Where is this actually called from? This is called from. Where's this? What method's this in? This is in. Oh, it's in Unicode escape. So if you give it a Unicode 32, really, it will actually work with it. That's, huh. If it's outside the actual character range, but it's still technically Unicode, it'll still give it to you. Nice, that's cool. Okay, there you go. I didn't know that, but I guess that's how it deals with the character range being limited to UTF-8, I guess. Interesting. Or is it 16? One of the two. One of the two. And you have your stuff here. Like you'll see a lot of comments here, because a lot of these stuff can't be made self-explanatory. It's like we need a refresher of like what's actually happening here, like why we reached this point in the script, because oh boy. But yeah, this is your end of comment line stuff. Oh Lord. Oh boy.
Yeah.
Okay, now we're getting in. So that's how they. That was the end of their utilities region. It's like half the file. Christ. Oh, it's nuts. I love it. Okay, so then you have basically this is where it avoids recreating things like string builders over and over again. It keeps a queue of these things. I think it's like 10 or something like that. Yeah. So it keeps about 10. It also doesn't want to keep any that have too much data in them, but basically anything up to 10, it will just make new string builders, but once it has 10, it just keeps them in memory. It doesn't actually get rid of them, it just clears them and then reuses them, which I guess would be a lot faster than recreating them the whole time. But I don't know, because I haven't tried it the other way. I'm just going to assume that's correct, because that's been there for a long time and it works very well. That's with a lot of things in this file, honestly. Sometimes you're just like, I'm not 100% sure what that does. I'll figure it out if I need to. But for now, it works. And most things are commented, so if you need to figure it out, it's there for you most of the time. This is all about comments. We're going to pretty much skip that because it's pretty straightforward. It'll just grab the whole comment and store the text as the extent, and then send it off. The parser actually discards comments as an interesting bit of trivia. So even though the tokenizer recognizes it pretty clearly, it completely ignores them once it gets to the parsing stage. It's just like, oh, it's a comment? Okay, whatever, don't care. So if you're actually parsing code with PowerShell's internal functions, you need to actually capture the tokens as well if you're looking for comments, because it doesn't care. You have to actually go looking for them yourself. I know Glenn Sarti was actually working on the PowerShell editor extension stuff for that, where it was looking at code folding, and he was trying to make it use the AST for code folding because it's more accurate. But obviously, when you have things like comments and like looking for region markers, which are also comments in PowerShell, it's a bit funky. So he had to do like both. But this is getString similarity. Oh my lord, that's a line. That's out of my depth right there. I'm not gonna talk about that one because I don't know enough about it. I'll look it up later and I'll let you all know.
Please.
Liebenstein distance. I feel like I've looked at that before and I'm not sure exactly what it is. I'm gonna actually just take a quick peek, see if I remember. It's, what is that? Okay. Oh. The minimum number of single character edits required to change one word into the other. Okay. So it's, you want to see how similar the string is?
Didn't know that was a thing.
Distance map. Where is that called from? I'm just gonna quick check as I go through, because some of this stuff I'm like, I've like seen it and I've looked at it before, and then I'm like, where did this come from? What is this? Comments. Huh. Is this a logging thing? What is this? Case new line. What's it doing on case new line? What's it for? This is for scanning to end of comment line. Huh. Weird. Oh, okay. That's what it uses to figure out if a signature comment is actually a signature, or if it's something that's like just kind of looks like a signature but isn't actually. Wow. Yep. I'm sure that works. I don't know exactly how it works because I don't know what the heck the Liebenstein distance actually like does for parsing, but it looks fun. I'll have to dig into it sometime because like, oh my lord. That's incredible. This is what it uses for the require statement, actually, the get script requirements here. Basically, you can use hash tables or just a module name or whatever you need. You can actually have required assemblies as well, I think, though I haven't seen one actually use that, so I'm not sure on that one. But that's just what it has a list of tokens that it pulls from that initial comment there, the requires comment, and then it goes through them all and tries to make sure it actually works. And if it doesn't, well, you failed. It returns this script requirements object, which I think is actually registered in the parser and will throw an error from there. It's hard to tell exactly where errors come from until you actually get one, so I'm not sure, but we could look into that later if we care enough. You have your standard, yeah, so you have your if it needs modules, if it needs an assembly, snap-ins, all that sort of stuff. And then it has whole function with all this stuff. Checks its parameters. It passes in variables by reference because those are actually just used. They're basically out variables here. It's predefined up here, and then it's like, oh, let's just check them, and then okay. And if you run into any errors, they're all reported here. Looks like, which is cool. So this is pretty deep in, but basically it's just a whole bunch of reporting errors if there's anything wrong with the require statement. My lord, there's so much here that's like, it's all necessary, but also like once it's done, you don't want to have to look at it again, honestly. And then it does have a required assembly, which is handled with, yeah, nice. It just returns the required assemblies and gets used that for sure. And then anything for the actual PS edition. It looks like a lot of this is actually possibly used in modules as well. I would guess it's reused, I'm not 100% sure. Okay, so it requires comments, strings. Oh, here you go. Here's actual commands. Wow, we're only at line 2029. That's a tokenizer for you. You scroll past a lot of lines before you find something that's that you actually need to look at. Because a lot of the time, if you do need to fix something or you do need to change something, you do not need all 4,000 plus lines for it. You need maybe a couple hundred at most. So this is the actual command argument. This is what it uses when you use the stop parsing token, I think, judging by that comment. So if you have a command like if you're executing 7-zip from the command line, and then you want it to ignore the rest of the, you know, the usual stuff it does for strings or for brackets or whatever, and you want it just to pass it to the command line, you use the stop passing token, which is the you know, the percent double hyphen, I think. But yeah, so that's what it uses there. Basically, it just kind of ignores all of its usual rules there, and it's like, here's a string, I guess. Sure. And then you have your string literals, which is your single quoted strings. Basically, all these functions that start with scan, they literally just get called when it sees, like, if it sees a single quoted string that's not like inside another string already, it will just call this, and it'll go through, get every character up until the end of the character. So while it doesn't equal the end of the file or that, and it will check if it's a single quote. It actually checks that before breaking, because if you have double single quotes, it just parses it as like a single quote. But if not, then it just breaks out and goes to the next token, and returns whatever is here. It also gets token flags, looks like. Yeah, if there's any errors, yeah, but it, you know, no flags as usual. But if there's any errors, it flags them before passing the token on, so the parser can tell you when you've screwed up. And then we get your string literal. It just pulls back the token here. But yeah, like, there's a lot of stuff that just, it'll call this, and then it'll call like a child function. I'll show you one of my favorites in a bit. I think we're almost there. That I've actually been working with heavily. And then there's your sub expressions. It looks for your typical dollar bracket expression, parentheses, brackets, whatever, same thing in my head a lot of the time, even though it's not actually, but I call everything brackets, even braces of brackets sometimes, you know, it is what it is. But yeah, so you're looking for anything in a sub expression. Basically it just scans everything and until it, look at this, if it finds another parentheses here, it just adds. It's okay. We have another one, guys. And then when it finds closing parentheses, it's like, okay, we're like one step out until it finds the end parentheses. Good lord. It deals with a lot of nested stuff, and like, you have your nested script stuff, then you have stuff like that. It just, I love it. It's so weird the way it works, but it works so well. I don't even know, like, oh my god, it's so strange. And you have your expandable strings, which is great. Basically, it doesn't actually handle the expanded strings, I don't think, although it does scan the variables separately. But beyond that, it just kind of passes them along once they're done. It gives you your flags, and it gives you, and it doesn't actually return anything other than the flags, because what it's actually doing is it pulled in that string builder probably by reference, or no, it doesn't even have to, because it's a reference type. It pulls in the string builder, adds to it, and then whatever called it will just have that reference already. So that's one of the confusing things here. A lot of the times you won't see out variables, you might see ref, but if you don't, you'll often see string builders, because it'll pass them in, this function will add everything into the string builder, and then it just kind of exits and gives you back whatever flags, like if there's an error or whatever. But if not, then you just have these string builders here. And it looks like it actually turns it into a base string and a format string, which is kind of funny. Didn't actually know that. Wasn't actually, yeah. So it scans it in, but then it scans in into the format string as well. That's so funny. Oh wow. So it just literally turns an expandable string into a format string behind the scenes. So it's the exact same as using your -f operator, just without actually using it. That's so funny, actually. I love it. And then it has a nested one for if there's your variable inside a string or the sub expression or whatever. And then this one actually returns the token itself. But yeah, like this one actually, you call this to get the token, but this one itself actually calls the other overload for this, which can get confusing, because if you have two similarly named overloads, you're like, okay, which one is actually used? Usually the token is used because it gets the token, and when it actually returns the token, it'll actually return all the string builder stuff like that, any of that stuff that it needs still there. Don't know if, I'm pretty sure we might have skipped past this, but the get string and release method basically just calls this, just gets the string out of the string builder and then clears it out for reuse whenever it needs to be used again. And you got a lot of stuff here. You've got a here string, scanning here. This is all just, you know, string here string. Once it hits the beginning token, it checks. It goes through, gets every token inside the string, and once it hits the end string token or a new line in non-here string stuff, all that sort of stuff, it will just stop there. Go, okay, this is the token, and if it doesn't have a proper ending, it just reports an error. It's a lot of code, but it's relatively straightforward in the logic, at least, which is nice. But when you're looking at it, you're like, what the hell is it doing? And oftentimes I've found myself just kind of staring at it for like 10, 15, 20 minutes, like, what is this? Okay, oh, that makes sense. Like, it just takes a while. But it's relatively straightforward once you, like, get past all the symbols, basically, because there's a lot of them here. Because it uses individual characters for everything, so it's like, wow, okay. And then it checks to see for the here string footer, because, you know, it can possibly be one, but it has to be non-indented and all that, and all those extra rules. And you got a literal here string, same as above, just without the variable expansion, basically. I wonder if you couldn't even... I mean, heck, you could probably like refactor that into like one function, just... But, I mean, I guess it makes sense to do it.
That did have the part where you have to end the here string at the very start of the line.
Yeah, that's, so you got the here string header... Yeah. The length. Scan possible here string footer, so that's what actually takes it here. Is that one up here, or is that up here? Yeah, this one here. It calls back to this one, and it just basically tests to see if it's the proper terminator, and I think it also checks to see... Yeah, so basically I think, is it that just at the end of every new line, I think? Yeah, basically, yeah, so whenever you get a new line, it's like, if it's... That's so funny. So it adds a new line, and then it checks if it's a here string footer, and if not, it just keeps going. Just keep scanning it. Whatever. We're just gonna keep going. Wow. It's very straightforward, but like once you actually work with PowerShell, it's like it's building complex logic out of very simple stuff. Which is really weird to see. Honestly, like you go through this code and you're like, oh, this is how it works. Okay, whatever. All right. This is the here string expandable, and okay, where are we at? So this is variables. Wow.
Oh my god.
Love variables. Okay, so variables. It checks for dollars or splat, of course. There's a note here saying, yeah, we already took that one. So I guess it would assume that the existing character here has already been there, so it just scans the rest of the variable looking for a name. It actually has a variable path here, which I think is actually used much later on when it's actually putting variables together in... I want to say it's in the var.cs file. Basically, it's where it handles most of the variable stuff, including like the get variable commandlets. And things like that. The variable path is handled there, so I know that is used way beyond here. Because it's not actually variable name, it's just like it just needs the path to work out what you're accessing with this weird syntax that it likes to use. But yeah, so you have a brace variable or you have a regular variable. And yeah, this is actually probably the only place in PowerShell's code where it actually actively has to use goto. I'm not really a fan of it, but there isn't really an alternative, so you just kind of got to deal with it at that point. Someone asks, why is PowerShell very slow? Well, there's a lot going on, is the quick answer to that. The long answer is a lot longer, and there are like 5 issues on the PowerShell Core repo about its speed and improving it, and they're getting better. They absolutely are. Dongbo actually recently merged a PR in, I think, the last release version. It was in like 6.2 preview or something like that, whatever it was, where he basically, I think he was working on the startup time, because the startup time was always quite slow. It's like 25% of what it used to be, so it's much better. But yeah, there's still there's obviously a lot of optimizations that need to happen in PowerShell. I wouldn't say a lot of them are actually in this tokenizer, despite the 4,000 lines that it has. It's very like ruthlessly efficient here. It's ridiculous. But anyway, So yeah, scan variable, just, we've already got our first character, we just scan for either the raw name, or we look for the braced variable syntax. And then, you know, your standard stuff here, where it ignores most of the typical variable rules for brace variables. And then once it hits the end brace, it just goes, okay, we're just going to skip the rest of it, we're done. And then it will just grab the string, and yeah, and if you have extra characters here, it'll report an error, stuff like that. In command mode, a dot or operating on part of the current token. Yeah, and that's how it handles your typical what's the word, array accesses or property accesses. Yeah, this is what it usually does. I think the only case it won't do that is up in here where you're doing the brace variable scan. It won't recognize your periods as the actual operator. But there it is. And then you, oh lord. Down here is where we actually get to the not brace variable. So it's all this is just for handling that and errors that happen there. Oh my lord. You're like, oh, this was like, oh, I was like, oh, is it down here? No, this is just where it ended the scan. Then it's got to check if something went wrong. Okay, wow, alright. And then it goes, okay, now we're going to get to a regular variable. And then actually, yeah, look at this. Actually, special casing these three special these three special variable names. Wow. And if there's anything else after them, it's like, no, you know, doesn't exist. And then you have your static member access, but it checks this first because this is also used for scoping. So yeah, so it allows scoping, but then if you have a double colon there, it'll actually just go. This is one of the cases where it has to unget the character because it actually has to go ahead and treat it like an operator later in the code. So it has to go, this isn't part of the variable name, we have to unget that and then keep going. So you have a lot of stuff like that where it'll be like the first character isn't necessarily definitive, and then it'll have to check the next one. If that's what it expects, it'll keep going. If not, it'll unget the first one and then keep going. Whatever's after this method in wherever it's actually at. Error handling, variables, parameters, and operators. In either case, it must start with a dash. Cool. Okie doke. So we're looking at scan parameter here. So, oh, really? It just does both in the same thing? Nice. Love it. And I would guess it would probably scanning. If it's not in command mode, it will unget it because that's not valid for an operator. Okay. Your null character is basically always a. No, that's the end, guys. Okay. There's standard stuff here. It'll append characters. Usual quotes. Quotes are never part of it. So basically, it parses them both the same and then checks if it's in command mode or expression mode. If it's in expression mode, it's probably fine. If it's in command mode, something wrong. Or it'll treat it as an argument instead. Okay, so. Whoop. Yeah. Your default cases here is just append, whatever it is. And if it's not in command mode, it'll stop. Okay. Get string release. It returns it, and then it returns the token. Yeah, a lot of stuff you'll like your string will just be buried in the token when it gets it back to the parser. Check operating command mode. Check operating. Oh my! Wait, we got two of these. What are these for? Oh, two different characters. Oh, two-letter operators as well. Okay, makes sense. And you have your okay. This is what it uses probably a lot of the time is your generic token. This is for any generic token is actually any bare string that it can't figure out is a parameter or. And sorry, not parameter, parameter argument or a keyword will be a generic token, and that is any of your commandlets are all scanned as generic tokens first. It looks up what they are later. If it's a bare string, it'll just be a generic token, and then once it gets to the parser, I believe it actually just looks at what it is, and then if it's a registered commandlet or a function, it'll be like, hey, call this, or if it's something on the path, it'll call that. You know it'll go through its list there. Who's adding me? I'll get back to that later. And so yeah, so these are generic tokens. Yeah, see, it's like 77Z, but so it has things like if we hit a number, we're gonna start parsing it as a number. But if we hit a letter that's not like a valid type suffix or whatever it is, we have to actually stop and be like, okay, this is actually a generic token, and it has to go all the way back. So there's a lot of skipping back in this section, which maybe could be optimized out. I'm not really sure actually. And move backtick, yeah. So there's a lot of stuff here that'll just be generic tokens. Here's the fun part. This is the part I actually played with the most. Numbers. Numbers are fun. This is their hex digits and decimal digits. Basically, it just loops through a string until it finds the end of the number, and will then return it, and it'll check if it's a number or not, whatever. A lot of try parsing happens there actually, which is fun. Okay, so yeah, this is just your yeah, so this one just literally just returns the string builder with the hex digits, and this one just returns the string builder with the hex digits, no, the decimal digits, and then it also returns the number of digits. I think because it also skips ahead at the end. I'm not sure. It's been a while. We'll see in a minute. That's coming up. You have your exponent, which is your number syntax, or plus minus whatever for exponential syntax is there, and your numbers with a dot for decimals or anything decimal or with exponentials that have a dot in them will. It scans the number first, then it hits a dot, then it tries to scan the number after the dot if there is one, and then just keeps going. And then here's the basically the main one that handles all your numbers. Try get number value. Basically, it passes in a string that it thinks is a number. Boolean for hex and real. I've actually changed that in my latest PR. It hasn't been merged yet, so I'm not going to show you it yet because it's not actually there yet, and it might be changed. But so far, yeah. So I kind of wrapped that up into a single thing because it's just easier when you have more than two things going on here, because we also have binary to deal with then. But yeah, so then you've got your multiplier, which is things like your kilobyte, gigabyte, megabyte. Those multipliers are added on after, and you have your the actual result of it, which is object type, because we got no clue what kind of number we have till we get through this. This is your default style. It'll allow leading sign, decimal point, and exponents. The very first thing it does is check if it's decimal. Pretty simple. Do a straight try parse, see if it works, and then does the multiplier. I did a bit of refactoring here in the PR I just mentioned as well, because as you can see, we have decimal try parse, we have double try parse, and then I think we have a lot of this convert change type, which is like, it works well, but it is kind of an more expensive operation than necessary. There's a lot of extra things getting passed around that doesn't really need to be. And I've got another way of dealing with that, which is basically just I have a couple helpful functions in another file that essentially just check if it's like within the right type bounds, like if it's small enough to be a byte or a double or whatever, and then if it is, it just does a straight cast rather than calling this method, which does a similar thing, but also just has error handling and can throw errors and stuff, which we don't really want in the parser at all, if possible, because a lot of the parser is just like, basically a lot of this defensive design is just designed to avoid as many errors as possible. Because if something throws an error for here, it better be serious. If it's like a minor thing like, oh, this isn't really a number, and it's throwing like a major error, it's kind of a problem, because then like it just fails to parse. So there's a lot of try catch here as well, and everything's in check to make sure there's no overflows because of stuff like this, which I think try and handle as well, just by doing the multiplier as a big integer or as a double, I think, and then I cast downwards. Basically just let it handle as much as possible without throwing errors and stuff like that. Yeah. And as you can see, this is just a mess of, once it passes as a double, if it's actually like, if there's no flag, then it just goes, okay, it's a double, we're done. But if it's anything else, it'll go through this list of different kinds of numbers, and it will just go through and do a lot of casting and do the convert change type to whatever it needs to be. There's one here, I think, so you have your unsigned long, but also the unsigned one as well. It has some extra logic in there. If it's like, if it wouldn't fit into a regular uint, it will just put it as a u long anyway, because that's how PowerShell works anyway with the regular signed numbers anyway. So it's like, I may as well go with that. But yeah, that's probably getting changed if my PR goes through, because this doesn't need to be this messy. It really doesn't. Really doesn't. It's so much easier. I'll actually show you what it is. I mean, I could probably just like do a quick change branch and show you. Let's have a quick check out. Let's see. I think this was it. Yeah. Okay, here we go. So, instead of all that, we instead get what looks a little more like lengthy, but it's just easier to read. We do a straight try-cast. We get the double as a big integer because that's what the try-cast works with, and we're working with an integer type anyway when we're doing these casts. So we get it as a big integer, and we take the out variable, and we just send it back. These try-cast ones are actually in here. They literally just check if it's within the right type bounds, and then return true or false. So it knows if there's an error or not, but there's no actual errors getting thrown, which can be a little expensive to do in a parser. It looks longer, but honestly, it's a lot neater than whatever the rest was. What do I call it? It's a lot neater with the extra spacing, I think, and the extra just self-documentation than this. Which, I mean, like, technically it's less lines, but also it's a lot harder to read, like, see what's going on. It's like, okay, I guess we're changing type a lot and casting everything under the sun, whatever. It's, yeah. But it works, so it's stayed that way for now. But yeah, so basically what it does, it'll just do all this, and if you get a false result, no, not a false result, sorry, this, in my PR, if I get a false result, it'll just error out, but in this one, it'll actually catch actual errors, and then it'll, further on down at the end of the try block, it'll actually just return false, and there's no result, and throw an error. But yeah, so then you have stuff like this where it like checks for hex digits. It actually has to handle negatives separately, because for whatever reason, the parser that handles the try pass mode that handles hex digits doesn't actually allow like negatives, because it expects like signed hexadecimal numbers. So like OXFF is like -1 for reasons, I guess. Which doesn't make a lot of sense to me, because in C# itself, if you actually enter a hexadecimal literal, it's unsigned always. There's no signed hexadecimal literals when you're actually coding C#, but when you do a try parse, it's like, oh, this is totally signed. I'm like, what are you doing? But yeah, so that's fun. So it has to handle that separately. It just negates the multiplier, because it knows it'll do that later. And you have your basic same thing. It just does a try parse, and then yeah, these are actually all separate try parses, which I'm not a fan of myself, because they're kind of difficult to work with. No, it's not so much difficult to work with, it's just unnecessary, because you're potentially reparsing the same string like 3 or 4 times throughout this method, because you got to try and parse it as a decimal, you got to try and parse it as a double. Actually, no, you don't have to bother with that, because it already flags it, but it will check for real, and it'll try and parse it as a double and all that stuff. So it does skip as many as possible, but there's still a few too many try parses when you can just do like 1 and just be done, which would be great. Which is what I did in my PR. I like refactored out all the try parses and just did one big try parse with the highest type possible, which I think was just big integer, because it will hold basically anything under the sun, and then or double, because that's the highest floating point type we have, and then yeah, and then just go for it from there. Same deal here, like it'll just cast things down, however it manages to work with. Now these are actually basically straight casts, because so it does the try parse, then it will have to cast the multiplier, because the multiplier is always a long value, I believe, which is problematic. If you're trying to return some other type, you have to actually manually cast it back down. Or if you're doing an unsigned type, definitely you absolutely have to cast it back down, because it just doesn't work out. Like, it will refuse to multiply unsigned and signed values unless you do a specific cast one way or the other, which is interesting, but a little annoying. And you're straight on down here, and then basically, if you get to this point, this is after we've checked all our flags, all our try parses, everything like that. And then if we didn't specify any flags, we're like, oh, okay. Or actually, if you specify invalid flags, it just is like, nah, no good, can't do it. But if you don't specify any flags, then it's like, okay, it does this. And I don't know why this was chosen. I can't really speak to why it was chosen. It seems like there might be a better way, but I wasn't able to actually find a better way without refactoring a lot of stuff. So I found a better way, but it required a lot of changes. So, like, this is probably the best way they had at when this was actually coded, because this literally hasn't changed up until my current PR. This hasn't changed since since PowerShell was open sourced at the very least, possibly before. Any of these comments you can see where it's like move files from the Monad modular super project is at the very least from when it was open sourced and possibly from before that as well. So it's, yeah, there's a lot of old code here, but basically it just attempts to try parse, and then it's like, okay, this one worked, and then once it's done, it's like, okay, now actually do the proper pass with a big integer and then cast downwards, which doesn't make that much sense to me. Like it checks if it works with this, and then it casts it actually as a big integer, and then just casts down again. I'm like, okay, it's a bit of an odd way to go, but I guess it probably made sense at the time. I don't really know, honestly. It just seems like there's a lot of duplicated logic here. Like you could just check the bounds and just do a direct cast rather than bothering to attempt the try pass at all. But yeah, anyway. But yes, that's that. So basically, if there's any exceptions, it literally just swallows them, because it doesn't care if there's an error. If there's an error, it just wasn't a number, and that's not important enough to actually throw an error. So you will never get like an actual error from this code. The error will be generated up in the parser where it's like invalid command name or something like that, because some numbers, or like some things that look like numbers, are actually just command names. Which is weird, but I mean, people do what people do, so they're allowed to. So yeah, if there's an error, it just ignores it, and then just goes, nah, there was no number here, sorry, and comes back. That one is actually called by this one, which is a little more, well, it's not that much more complicated. Basically, you have your defaults here, which are nothing, and then you do the scan number helper, which is what actually processes the string to whatever number. That's where a lot of the things like figuring out what type it should be happen. We'll go down there in a second. This is basically, once we scan it, if we don't get a null, then we try and get the number value, and if it fails, then we just report an error. It's fine. And then we go ahead. This is the actual scan number helper, which, okay, so basically it gets the starting character of the number. It gets two flags, or it rather sets two flags, which if it finds a hexadecimal or a real number. Real numbers are basically what it just defines them as anything with a decimal point, or with the E for exponential stuff. Either of those will register as real and get parsed as a double instead of anything else, unless you have suffix flags. I also add suffix flags that has the multiplier as well. So the multiplier is determined in this method as well. It sets your defaults, so, you know, no suffix flags yet. It's probably not hex or real yet. We don't really know. And your multiplier default is just 1. And there's no sign index, and we think it's a number so far, basically. And then you get a string builder, and you just check through your characters. First thing it does is check for positives or negatives. Notice it actually checks is dash, so you could technically use an EM dash for like a negative number if you really wanted to. I wouldn't, but you can. I don't know how like good that is for compatibility across encodings, but whatever, who cares? But it's possible. And then it'll check for actually any number beginning with the period is also a valid number as well. It just assumes 0 first and scans the number after the dot. This is where it uses a lot of help methods, like get string builder. We'll scan the number after our dot. We'll go ahead, and if we find a 0 if our first character is a 0, and then we have an X, then we'll basically treat it as a hex number until proven otherwise. And we'll go ahead and scan the hex digits, and what happens is if it doesn't register as a hex number, like if it runs into unexpected characters, this string builder will be cleared before it comes back, so it will be 0, and then it's like, oh, it's not a number. Okay, whatever. And otherwise, we just set hex to true, and we keep looking. The else here is basically anything else, so if it's not hex, it goes through here, it'll check for dots, it'll just grab your usual decimal digits, and just tack them onto the end of the string builder as it goes. So yeah, it'll put the first character in, then it'll pass it in here to scan the rest of them, and it'll keep going. And then if it hits a dot after that's done, it'll just scan the next section of the number and keep going. And then same thing for an E. It just basically essentially just does a second scan. It's like, okay, cool, we're good. and then it comes out of here, and then it checks the next character to see if it's a type suffix. And we have 1, 2, 3, 4, 5 in there at the moment. I have one more being added at some point. Okay. Yeah, peek is very, very handy, gotta say. But yeah, so literally all this is if it's the right kind of character, we'll just go ahead and flag it with whatever flag it is. If you don't do much C#, you might know what that operator is. Basically, it's a binary or equals, so it takes whatever it's the same as this. So if it would be the same as me doing like this, it would be equals suffix binary or number of suffix flags. You know, I can't spell. I usually have type completion, but I guess the live share doesn't like it. So yeah, it's the same as that. Basically, it does a binary OR because they're flag values, and you can have unsigned short, unsigned long, unsigned nothing else technically, but you can have the unsigned in combination with a couple others, so it will allow that. And it's just basically just to save me coding extra specific cases for those. And then once it gets to here, it'll just double check again in case we have a second type suffix character. So if it's already unsigned, we can check for L, S, or Y, which will all be unsigned versions of these. And they do have specific names, but I don't set them explicitly just because just in case something really messes up and it like ends up with accidentally, you know, getting some weird extra flag in there that shouldn't be there, it will come out as an error and not just treat it as, oh, this is totally a valid suffix. Which shouldn't happen, but I mean, if someone's messing with the code and they accidentally add one like in there that doesn't quite work out, I would much rather it throw an error than just like still pretend it's like one of these other things. So yeah, just trying to make sure like if something goes wrong, you get an error. If it's not a big deal, there's no error. Is basically the motto of this tokenizer. You will see try catch sometimes, but you will pretty much never ever see an actual throw. I don't think there's a single reference to throw in here ever. If there's an error, it will use the inbuilt like diagnostics assert this or report error if it's an actual like script error. But if it's like an error in the code here, you'll usually get a diagnostics assert error, which prints out a message and then usually like a stack trace, I think, which looks fun in the console when it happens. Let me tell you. And then once you get your type suffixes done, then it goes through and checks through the multipliers. So it doesn't actually really care that the second letter is B. It checks it just to make sure because that's what the syntax is. But it really only cares about what the first character is. That's what sets it. And then if it's not B, it's like, oh, whoops, sorry, it's not actually a number. Like it doesn't even care. It's like whatever, it's done. Doesn't matter. So it's just funny the way they do some of these things. I love it. It's great. And then you have, so if you're not setting your token, so it's not forced on your token. If it's not expression mode, right? So if there's no space or there's something unexpected here, basically after the number, it's probably not a number because it doesn't end with like a space or it'll end with something unexpected. Though obviously, you know, semicolon after a number is perfectly valid, so it checks for things like that and commas. So if it's not a number, we just return null. We don't even care what it was, what we thought we had. Just it's nothing. We'll just get rid of it. but notice how it's not like get string and release or whatever, because it doesn't matter. We just release it. We don't need it anymore. It was a red herring or whatever. And then you'll note here that actually internally happily just replaces any kind of weird dashes if it's used for a negative sign. It'll just be like secretly replace it because the try parse doesn't accept it, but we want to deal with it, so okay. And then it just goes, okay, then we just get the string and release, and it sends it back up to this method here, like a billion lines above. And then it just does the try get number value that we covered before. So those three work pretty well together. I have, if I go ahead and check out the other one again real quick, you can see how I've changed it a bit here, which probably will end up being the way it ends up. I'm not really sure. I reformatted some bits here that I didn't like and things like that. I turned this into a switch rather than like a bunch of ifs. which in theory is probably slightly faster, but it wouldn't make a big difference. It just looked a lot better to me. I was like, I don't like how this looks. I'm changing it because I'm here anyway. Whatever. And a lot of these things, I actually changed to using spans for some of this rather than strings. I don't know if it makes a massive difference, but it is easier to divide it up when I need to, because there are a couple of cases I do actually need to cut up the string that is passed in. And you can see I've changed the hex and real. I've just put them in here. It's number format thing now. It's just another enum that I put in, and then it gets passed along. And I think in here, if I went down, you'd probably see, yeah, binary digits. I handle binary digits here. This also checks for if it's hex or if it's binary before doing anything. Just basically checking for a different character essentially. And yeah, so it has a helper method scan binary digits, which we'll just peek at here real quick. It's basically the same thing as the hex digits. Where's hex digits? It's here somewhere. I think it's above this. There you go, hex digits. It's basically the exact same. It just calls a different extension method on the character to check if it's a binary digit. I could just use like 0 or like 1 or something, but it's just more clear when you're reading back through, like, oh, it's checking for binary stuff. Okay, fair enough. And once you're done here, then it checks for your usual real and exponential stuff. And I think if I have, do I have it in here? Yeah, I have an n suffix for big integer, because like, why not? It's already using it anyway. May as well, right? But yeah, let's go back to the actual one now for the time being, because that's not in there yet. Sneak peek. Okay. And so where are we at? So we've skipped ahead a bit because I added so many extra lines. Where are we? That was numbers. Okay. Then you have your member access operator. So this is for. Yeah, that's interesting. We do skip multi-line comments. They are allowed. Really? You can stick a multi-line comment? Oh my lord. Really? Oh god. Okay. So yeah, apparently you can just jam a multi-line comment inside your variable expression. So you could do like variable dot comment and then member name. Like, I don't know why you'd ever do that. I think let me see if it works. Let me get like a here. We'll just get like a string. I don't really care what it is. I just want to see if this works. A string. So you should, if that comment's accurate and I'm reading it right, you should just be able to do this. Yeah, you can. You absolutely can. I don't know why you'd ever do that, but you can, apparently. That seems like a terrible idea, but go wild, I guess. like literally some of the weirdest stuff. You're like reading through this. You're like, can you actually do that? Okay, all right, whatever. It's so funny. Oh god. So yeah, it just skips multi-line comments. It doesn't even care that they're there. They don't exist to it. Who cares? Oh good god, why? Why is that whatever. I'm not gonna question it. It's there for backwards compatibility. I don't know why that was ever a thing. That's so funny though. That's wow. Okay. Alright, so we're gonna go back to, so this is the member access stuff if you're doing stuff like this, or if you're doing like it's in the console, or if you're doing static member access as well. This is where it handles that. Yeah. So you would go ahead and pull this in. And what is this playing? I feel like I know this song. What is this? Maybe not.
Obstacles.
Maybe not. I don't actually know this, but it sounds familiar to something. Similar. Anyway. Anyway, yeah, so it just checks for your typical, come on, your typical dot access or your colon access. So technically they're not like actual like operator tokens or anything like that. They're just kind of handled as operators because it makes the most sense. But if you actually dig into the abstract syntax tree, you will not see, I'm pretty sure you won't see period for member access or that as like a static member access operator. It's basically an operator, but at least internally it's just handled by whatever character it is. It's not actually an operator in the actual code, because there was a list up there and these weren't in there. So it's yeah, it's a bit funky the way it does some stuff, but in some cases it just makes more sense. Especially because they're like these specific characters and it's not really used that much. It does have a colon kind, but it's not like it doesn't register as like an operator. It's like, oh, it's just a colon. It's a dot. I love that name. It's great. No one wanted to write double colon. I guess they was like colon. Okay. All right, and then you have your. I don't know when you'd call this and allow your L bracket. When would you do that? Not 100% sure on that one. There might be some cases though where I would allow it. Though I don't know exactly when. Interesting. I'll have to look into that later. Invoke member open parent. So if you're invoking a member method like this, that's where it registers this. It's like, oh, there's an open parentheses. Okay.
Okay.
Or if it's this, it actually handles as well, because you have things like, what's it called? You'll have that, which it also handles in exactly the same way. It doesn't even really care. But of course, when you're using that and not the actual parentheses, it only allows the one argument, which is fine. But yeah, so it handles that here as well. Like it's not, it has to handle it on like a language lexical level, because otherwise it'll just get skipped because it wouldn't have been registered as like a parentheses. It's kind of funny, but basically parentheses are like their own like little kind of token. I'm not sure what value that has, to be honest, because I need to get more deep into the parser to really fully understand that, but basically, yeah, literally almost everything will be its own kind of token, and you have tokens for stuff like this that look kind of like operators and behave basically like operators in that context, but they're not really. It's a little wonky how it works, but I mean, once you get used to it, it's pretty intuitive. It's just when you're like getting down to the bare metal here, it's like, oh, this isn't an operator? That's surprising. Okay. Okay, so to get L bracket, alright. You expect an attribute, type constraint, and allow any white space or comments, but nothing else. Okay. Generic token may begin with that, but we don't want anything more than that. Okay. So if it's expecting attributes or type constraints, and it needs a square bracket, it'll just get a square bracket. It has a whole help method for it because it's surprisingly complicated when it has to deal with comments and everything else. Yikes. Look at all that nonsense. Nice. Yeah. And you have your scan dot, which just looks for a dot. If it's a dot, it does what it's expected. I think actually this one is used in. Where is this? Is this in your L bracket one? No, this is something else. What is this? This is. What's this big switch for? Let me see. This is again. Oh, this is next token. Okay, so this is where it classifies each token to check what the next one actually is. Is that here? No, this is get L bracket. It looks similar, but the get next token will call this when it finds a dot, because it could be a number, and it will check. Yeah, so it'll do a P character. If it's this, we do that. If it's actually a decimal digit, then it's that. So yeah, basically at the point where it's reached scan dot, it'll have already hit a dot, and it's like, hey, we've got a dot. We're gonna scan to see what's beyond it. If it gets a second dot, it's actually the range operator. Token kind dot dot apparently is what they call it internally. Nice. That's what they use for the range operator basically. And this is your actual decimal digit. If it actually goes ahead and does that, see if it just kind of sees if it actually works. And then if not, you just get a dot. Just a dot. It's all good. Dotted command. So this is what it uses for dot sourcing and stuff like that. So when it reaches a dot, it'll check for a number. It'll check for your dot range operator, and if it's neither of those, it might be a dot source if we're in the right sort of mode. So if we're in command mode, not expression mode, not any other mode, then it could be used as a dot source. So we'll see if we have a generic token after that. That one doesn't really ever fail, honestly. But it's important to remember that not everything is actually like a valid dot source, so an error for this one would probably be generated when it actually tries to parse that and see if like there's a script by that name or whatever it's trying to work with. Okay, so this one here, the first character is an ASCII letter. It's getting a keyword, command name, argument, method, proper name. So yeah, so this is, yeah, when it's basically a step past the space, and the first thing it finds is any letter. It'll just go through this, looks to see if it's a keyword, command, argument, method, proper name, stuff like that. When it gets to this, it'll just go through, make sure everything's letters and whatever else. And I don't think there's anything where it actually, yeah. In expression mode, we only want simple identifiers, so we're done. We're done here. But in command mode, we keep scanning. So yeah, so there's a lot of convoluted, like, in this case we do this, in this mode we do this. It can get a little hairy, but as long as you like have an idea of what you want to do, it's not too bad. Famous last words. But yeah, it's not too bad. Then you have scanning for type names. Just keep scanning for okay. If it's letter or digit, continue. So yeah, any of these, it'll just continue and use it and attempt to find what the actual type name is. But if it's not, it breaks. So it finds the next thing and just breaks. And then it tries to do this, and then it, what's this? Result, token flags, type name. Where did this come from? Where is, oh right, so it just flags the token with a type name and returns it, and the possible will eventually come across that and be like, oh, it's supposed to be a type name. And if it's nothing valid, then the possible will throw the error there, but here we don't even really care. We just care that it's got some characters that are probably valid in a type name somewhere. So that's like a lot of what the tokenizer is. It'll just check for stuff that is probably valid, but it doesn't actually like really parse the code itself. That happens in the parser, which is a much bigger file, which I'll show you guys in a little bit. Maybe just a quick peek, but it is ginormous. It's crazy. It's scary, honestly. Like, oh my god, the file's massive. Not as big as the AST though, I don't think. The actual AST file, yeah, this is a big boy. What is he? 10,000. That's not too bad. 10,000 is not too bad. What's the parcel like? I can't remember. Yeah, similar. 7,500. Okay, yeah. So it's pretty big. There's a lot there. Basically, that just takes all the tokens that this thing creates and figures out exactly what it needs to do contextually. You know, if it needs to be a command name, if it needs to be like a parameter argument, and pass those in. You know, get variable values in, stuff like that. It will handle basically all that stuff. It's crazy. Goes through the AST and just puts it together. Yeah, the AST is interesting to work with. There's a lot of nested stuff happening, so similar to this actually, but a lot more, I think, honestly. Because the AST you can access basically, it's almost like you can access just about any other connected member from any other AST member. So you end up with a lot of like going to the parent of this, getting the children of this, and yeah, it's insane, but it's great. Assembly name stuff. Get assembly names back. And you have your labels for labeled loops, I believe that would be. Yeah, it must be generic token. Yep. We append the colon for the label name, and then we just keep going. And this is what it does when it so when it finishes parsing one token, it just calls next token, and then we check again. Wow. Yeah, so it pre-stores the start of the token, so that if it goes down one route of parsing it that doesn't work, like for example it starts with a number, it'll try and parse it as a number, but if it doesn't work, it'll just unget those characters and go back to the token start and then attempt to parse it like a generic thing. So this is like a reference point. If we get too far and there's something that doesn't make sense, we have to go back and parse it as something else or just report an error. Then we have the token start there to basically keep track of where the heck we are when stuff gets hairy. There's your typical stuff for the white space. Just skips it. Doesn't even really mind. It's like, okay, whatever. And then you have your string literals, your expandable strings. As you can see, it basically registers most quotes as the proper quotes, which does get a little interesting because I think, if I'm not mistaken, it checks for. Does it? I don't know. I'll go check later, but I think it has something where it checks to make sure the opening quote matches the closing quote style. I don't recall exactly. Maybe not. I'll have to look into it. I can't remember exactly. I feel like I saw something like that at some point, but I'm not sure if that was in here or elsewhere. But yeah, so then you have this one, which could be a lot of things. Could be a hash literal, could be your array, could be your multi-line string or a splatter variable. So this is used for a lot of stuff. So it just checks to see what the next one is basically, and then does the appropriate thing. Comments, new lines. You have your escape characters there. It actually explicitly checks for a line continuation. And I know Thomas had a look in here earlier, Thomas Rayner, and he put in a thing where he basically copied a similar thing to this, but I think he used, I can't remember exactly what it was, but it was some sort of emoji that could be used as like a line continuation character. I think it was like a heart emoji. You just like end a line with a heart, and then it's a line continuation. I was like, oh my god, Thomas. But like stuff like that, you can just do it. Like it just does it on a per character basis. So if you wanted to add something weird like that for kicks, you can. I don't think it'll make it into like actual PowerShell, but you can. Like it's definitely something you can do. I mean, I tried to talk him into submitting that PR, but he didn't think it was likely either. So I mean, it'd be a funny Easter egg, like end a line with a heart and it just like a line, and it just continues a line. That'd be kind of funny, but yeah. So like you could literally just be like, okay, we do this, and then you would just copy like this section, I think, and then you have to add some extra logic in to make sure that if it's not like a new line, then or if you don't want it to behave like exactly like a backtick. He wanted it to be just a line continuator, so he had to strip this out of his copy, and then I think he had to like loop back in and like just keep scanning or something like that. It was so it didn't just escape the next character as well. It would only escape line continuations, which I thought was a neat idea because it's not a bad idea to have a specific line continuation character. But yeah, so that was that, and it just gets the backtick and your generic token after that. And you have your equal sign, your assignment operator, checks in command mode, and your other operators here are all here. You'll notice that all these are also handled only really by, what's the word, sorry, my head, are only handled by character. They're not like a specific enum type or something that says these are operators. These just kind of are handled as is, as characters. You could probably make an argument that you could maybe put some of this together, but in the end, even if you did have a single case for it being like, this is an operator, or a mathematical operator, whatever, you would still have to probably do an if or a switch or something to see which operator it was, so it probably just made a lot more sense to keep them as single characters in this case. They definitely are effectively operators in PowerShell, like the dot operator and stuff like that, but they're not explicitly operators in the way that things like split are, because those are specifically just defined as that kind of operator. But essentially in PowerShell, the only things you'll see defined as an operator in the code will be stuff like this, minus, minus, and minus equals. That's so funny. They're very literal. Like it's not double plus, it's plus plus. Okay, like I love it. It's so funny. But yeah, so you'll see a lot of things in the code here where it isn't like actually registered as an operator until it hits the parser, whereas things that are really, really obviously an operator are going to be, like the thing you pointed out before, like shift left or like split or join. They're just operators because there's not really anything else that is allowed to use that specific string. If it's that string, it's going to be an operator unless it's like wrapped in a string or something like that,
Yeah.
So, yeah, so these are just handled separately. Division, your modulus. Okay. And you have your dollar operator here. We'll go ahead and scan into new token. So if you're, so if you have dollar and then follow it by parenthesis, then you'll just, okay, we're just gonna scan the next thing, because it doesn't really care at this point what the next thing is, but it'll figure it out in a minute. It's like, we'll get to it in a minute, big deal, whatever. Otherwise it'll just be scanned as a variable. You have your block comments, or see this here? This is actually handled as an input redirection token, which is really interesting because that's not even supported. If we look at this, it registers it in as a token, it passes it to the parser, it's like a totally valid token, but you can't use this in PowerShell. You literally can't use this. No, like if you actually try, for example, if I put in like this, right? It's reserved for future use. It's all in here. It's like the framework is here, ready to go. It recognizes exactly what it is, but it doesn't let you use it because that logic's just never been put in there. I know, so I don't remember who it was, but someone was asking me the other day about if like we could make that work, because it's like it's like used in a lot of shells as like an input as like redirect input to this thing or to this command or whatever. And yeah, you absolutely could, because this code is already here. You don't even have to worry about the tokenizer. You just have to figure out where it handles these tokens, where it would handle. So yeah, so wherever it would handle this, and the tokens that it gets from this, you would literally just look for that in the parser and then figure out how to handle that. You would probably be able to take pointers from this one actually, because this is your file, redirect to file, and you could probably just handle it in a similar way, unless you wanted to also let it handle like like weird stuff like this, like I don't know why you do this, but if you had like a variable or something, you could maybe do that. I don't know why you'd want to do that, but like in theory, you could also make it handle that as well. Why not? I guess, I don't know, but yeah. So you could overcomplicate it if you wanted to, I guess I could say, but otherwise you would probably just do a pretty much copy paste of whatever happens with this one, just with these tokens instead. And then, instead of doing a set content, you do a get content, and it would be relatively straightforward. You would probably just have to handle cases where you're trying to input it into a commandlet and figure out how and where you're going to pass that to in the variable. Like, yeah, you're going to handle like pipeline import or something like that, maybe. No, I'm not sure how you do that, but it's definitely very doable. It's just like this code's already here. It's just waiting for someone to make it happen, honestly. You have standard letters. I'll get to that if I get to it, or someone else can get to it first. I don't really mind. That's not a big one on my list. Although I know a lot of like Linux people really are used to that stuff, and that's great because I know they I've used something like that in F# because F# has a similar operator. That one would be very tricky to make happen how it happens in F# though, because in F# it's less an explicit like input thing. It's literally like they have this thing called currying where you can kind of half make a function. So like you can call a function with like partial arguments even though it requires more, and then what it returns is like a copy of that function that still requires those additional arguments. And then you can call that one with only so you can create like a surrogate function that has like a predefined argument. It's so weird. It's great though, but you can use it for stuff like that to like pass in a predefined argument and stuff like that. It's weird, but it works, I guess. But yeah, it's not something that would make a great deal of sense in PowerShell, I think, especially because like we have the pipeline. Like it's not a major pain point where we can't redirect input very easily. The pipeline kind of works for that,
Yeah.
So it's not a huge priority for most people, but some people really adamant about making it happen. Like, hey, look, it's already here. Go for it. Go wild. It's right here. Make it happen. The hard stuff's basically handled for you. Well, not really, but the beginning is there. It already recognizes the token. It's already waiting to happen, basically. This is just what this is just how it is. Because whenever it reaches a new token, it's like, we're gonna scan through, see what the heck to do here. So if you wanted to add a new type of token that had a specific starting character, I don't know, whatever you want to do. If you wanted maybe to let numbers start with just an X for a hex rather than 0x, you would have to put a case in under X for that, and then you would have to modify a few other things as well. But yeah, you could definitely just mess with stuff here, honestly. Not gonna lie, you could just mess with stuff, whatever. But yeah, so that's always fun. And then you have this massive stack of switch here, which just handles basically what to do with each character. It has an and as well, and I don't think that actually, yeah, the unimplemented operator and. Yeah, that's what I thought, Punk. You don't have that. I didn't think so. So these are there as operators, but if I'd actually try it, if I do that, it's not a valid statement separator in this version. So like, it's just not implemented, but it's there, and if you wanted to make it do something, you probably could, because it's already there, it's already waiting to happen. I wonder if I could... Yeah, it's already here, and you could check the references from here. And this gets used where, oh my god, I have to, yeah. This theme doesn't handle the peaking well, I should change it, but anyway. Yeah, parse an amount is similar to a pipe, but issue an error. So you would change one of these cases here in the actual parser file itself, it looks like. And you would just change how the parser handles it, remove the error, and keep going. So yeah, you conceivably could just make this do whatever the heck you wanted it to do, and see how it works. There's usually, so what usually happens with stuff like this is you'll make it do whatever you want it to do, and then you have to figure out, usually from context clues and like looking at in similar cases in the relevant files in the parser and stuff in the tokenizer, you have to like figure out how to make it do what you want and then go back to its normal operation, which isn't always entirely obvious. There are a few spots where it's like, well, like, how do you really get it to handle this back as normal input after we're done with this? But it does usually do okay. There's a couple weird places that take a few minutes to figure out, but most of the time it's just like, if it's not working as you expect afterwards, it's probably because you didn't make it go back to its normal behavior afterwards. It's like probably like waiting there like, was this the end of the file? No idea, because no one told me, like, sort of stuff. So you'll have stuff like this is your OR operator, your NOT operator, yay! And you have, there's like a mini little scan number helper in here. Huh, interesting. Interesting. Yeah, so it checks if it's a number after this. Wonder why it doesn't actually just call try scan number. Weird. That's interesting. Huh. I didn't really think it'd just... Yeah, it basically re-implements half of scan number down here whenever there's a NOT operator, which is interesting. I should take a look at that later, see if I can maybe refactor that out and just call the actual function. Weird. That's interesting. Anyway, and then it has a token kind exclaim for the NOT operator itself. Love it. And here's your other stuff here, you know. And that's basically it. Like, literally, the tokenizer just crunches stuff together, puts tokens together, and then hands it off. But there's a lot of like work that actually goes into making it happen. So it's been like nearly an hour. So I feel like, if you don't mind, Shane, we could go through and have a quick check with actually adding a new a number type in here if you want to see that happen.
Yeah, works for me.
All right, awesome. So what I actually have one in mind because I've already kind of done it, but I'm going to show you like how the process works here because I've done it a few times. I'm going to add a new one in. So what we need to do first of all, because this is just going to be a simple one, I'm not going to go too crazy. We're going to add in imaginary numbers, complex numbers, because they're actually already in .NET Core. They're just not really used much, so we're going to make them use them. So let's what we're going to do is we're going to go into character traits here and focus. And we're going to go ahead and grab and add on some additional character traits to the definitions here. So we're going to add in one here. Actually, no, I don't need to do one here. I need to do it elsewhere. But so what you would do is you would go into here. You would add in to whichever. In this case, you need to use the type suffix character trait. You would just add that on to the additional ones here. They're all like binary ORed because it's a flags thing. And we'll do it on both uppercase and lowercase. This is just like an easier way of actually working with the binary bits. It's just less messy to use the names and binary operators than actually having to do the binary math. So we'll add in type suffix. So now it recognizes that I and uppercase I are actually type suffixes. And if we actually were to build this, can I do that? I probably can. Let's see. It would probably... It should error out if it did its job, if I've done my defensive coding well enough in the previous stuff I've done already. So if we go ahead and build it, I'm going to actually just do a quick clean build here. It'll take a few seconds so we have time to do a bit more. But basically if I build and ran this now and I ended a number with an I token, it would think it's a number, but it wouldn't be able to parse it. And I think the usual error it gets in that case is it's an invalid numeric literal or some nonsense. It tells you roughly what it is. It's like, it's a number, but we have no idea what kind of number it is, which would be what you get here, because we've given it a type suffix. That really should be renamed, honestly, like to numeric type suffix or something maybe, but whatever. It is what it is for now. I'll maybe change it later. So that's basically what we need to do here, because that's all you need. You just need to recognize these characters as a type suffix. Then you come into your tokenizer, and the first thing you want to do is, we're going to skip past try get number value. We'll do that last. We'll actually go down to scan number here. And so this is here, we've got hex and real. We don't really need to add an imaginary here, because we're just going to do it as like a type of number with an I suffix. So what we'll do is we scroll down here in scan number helper, and come on VS Code, don't fall apart on me now. There we go. Come on. Oh, come on. Okay. So this is our type suffixes. So here we would do put in an extra couple cases, case I and case lowercase I guess, convention, and then we do suffix or equals. I actually need, so this is what I forgot to do. I need to add an actual suffix flag for this. So you do suffix flags. I'll probably call it complex. That doesn't exist yet. It's about to. So if we go ahead and go to definition on this, it's in this file. It's just got to skip up a bit. Come on. Oh, it's trying to figure out where it is. Come on, man, you got this. I know it's a big file, but whatever.
Well, you don't need to break after the complex, do you?
I'll check back in a sec. What is it? Yes, you're correct. Absolutely. Yep, absolutely. Yeah, good catch, good catch. Yeah, you can't fall through cases on C#, so I wish you could actually. It'd be really nice, but they don't allow it. So where's my where is it? Let's go down a bit. I'm just trying to find my enum here. Normally I would just like go to definition, but it's being slow right now. So there we go. So we just add on one here. Important thing to remember with flag suffixes, if you've never used them before, you have to basically make each one the double of the last one. So you'll notice that I have none is 0, unsigned is 1, signed is 2, short is 4, but you can add combination flag names. So if you had an unsigned byte, it's not just like, even though yes it is OX3, its actual definition is OX2 plus kind of like plus OX1 basically. It's both of those together. So you can't like, you couldn't define a totally different thing as OX3 because it's a flags. When you're defining different things, you need a double. If you're defining combinations of things, you can just add them together and create a new name for it. But if you want like a different thing, if I had, for example, defined that as short, I would have issues where it would think it's both signed. It would think it's both unsigned and a byte at the same time and a short, and it would probably mess up my logic, something awful. Yeah, not good. But yeah, so we're just gonna add another one in. So the last one is decimal OX10, and note this is actually in hex as well. So you can go. It doesn't matter too much, but you just got to not forget the OX, because here, like, you could go like OXA, which would be unsigned long plus unsigned again, I guess, which would make any sense, but whatever. I guess it would technically be OX8 plus OX2, so it would be like signed byte and long at the same time, which would make any sense. So don't, but you could. So we'll add a complex definition here. That can be OX20 for now. You don't have to end in a comma, but it may as well. Okay, so we'll save that real quick. The VS Code's still struggling, that's fine. I don't mind. Okay, so then we'll go back down to here. Back to our thing here, so that should register proper. Good, it figured out that was a good thing. Alright, good, so that's set. We don't need anything in here because an unsigned complex number isn't really a thing in .NET Core, so I'm not really going to bother at this point. And then that's really all we need to do here, because as long as it gives it the right flag, that's all we need. That's all we need to worry about right now. So it's got the right flag. Then we can go up to where we actually parse our numbers, and we can go ahead and where are we? So we'll need two cases. We need one to handle if it's been registered as real. So if you did like 1.5i, you probably still want to work with it because complex and real numbers work kind of hand in hand all the time. So we'll add in an extra case here. So we just do case number suffix flags complex, and then what we do here is going to be interesting because I need to actually convert that as a double, don't I? What I might do instead of doing all the convoluted change types is really we can just literally get the double value and the multiplier and work with it like that. I think would be best. So we'll just take, what is it, just result double value. Okay, let's copy this. So we can't quite do this because we need to return a complex number. So what we would do in this case, because complex is actually a struct, we can just go ahead and do do we have using system numerics in here? Because it's in system numerics. We do, perfect. Okay, so we're fine. Okay, so we can just go ahead and do complex, new complex, my bad. C# syntax, man. New complex, and I think that one takes a real and an imaginary part. So we're gonna put the real part to 0 because this is just gonna be the imaginary portion. And I'll show you how this works in a minute because I've messed with this a little bit. Basically, what it ends up with is a syntax that looks very much like you would actually write a complex number in is it polar coordinate form, or is it whatever the other form's called? Not polar form, non-polar form, whatever it's called. So you would just return a complex number using the double value you have as the imaginary value. And then what we're going to do is we're going to go down a little bit here, and we're going to get, so under here, which is where we handle our flags here. So basically the parsing is mostly split in two places. You have handling for real, and you have handling for integers. So we're going to handle the integers as well here. So we would do a similar thing. Number suffix flags, complex. Oops, can't spell. That's fine. Who needs to spell? It's only like very important. And you would do, let's see, you would do results equals, I guess you kind of have to try parse again. Yeah, you probably would try parse again here. I guess I can do that. So we'll do, it's easier after my PR, honestly. I'm not gonna lie. I made it a lot easier to work with this thing. It's a little tricky at this point, but that's fine. So we try parse it with the string number, style, number, format, info, invariant. I'm sorry, info. Let me do an out double. Let's call it D, I guess, is fine for now. Probably. We'll find out when we compile it, I'm sure. Even though VS Code doesn't want to let us know right now. That's fine. Do we have? Oh, it's just being weird. Okay. All right. So you would do this. So if it try parses correctly, you would do results, and then we just get a new complex again. Same deal, basically. 0 for the real and D for the complex portion, and then you would do a return true as well, wouldn't you? Now, did I do the right thing up here? I can't remember now. Yeah, we just break out of here and return true when it's done. Okay, yeah, so fine. Cool. Yeah, the structure is a little different. Okay, so we return true here. Otherwise, we do results is null, and we return false directly. Who needs to switch? Okay, so this is not cannot convert from out double to out use short. Oh, yeah, because I'm dumb. Because it needs that. It's supposed to be double try parse. Silly me. Okay, so that's done. And in theory, that should work. So if I get it to build again, that should TM actually work with putting complex numbers in. So yeah, we'll see. Okay, so yeah, we're pretty good to go. It's just building right now, and But yeah, so it's actually not that complicated to add like a number type. Probably the hard part would be if you have, I don't know, like a really like something that isn't actually in .NET Core yet, and you want to like define a new one. That would be a bit of a mess to try and put in PowerShell. You'd probably want to put it in .NET Core first, unless it's something really PowerShell specific, which I can't really think of an example of off the top of my head, but I'm sure there's something somewhere. But yeah, this and the parser and the AST are probably the three most complicated, most convoluted parts in the code. I would be pretty confident saying that. I'm sure there's a couple that come close, but I think these are probably some of the most convoluted ones. The parser especially, and absolutely the AST, because there's so many like helper methods that just make it really hard to follow what's going on. Even though it makes sense what they're doing, but actually trying to figure out where it happens, oh my lord, you're gonna be there for like a good half hour. Alright, so it's built. Let's check it out. Let's go ahead and run this puppy directly in the console is fine. Let's get it starting up and see how it works. Or if we didn't get a compiler error, so at least in theory it should be fine. Although I cannot even count the number of times I've not gotten a compiler error and it just like fails to work completely, so usually my fault. In fact, always my fault, but you know, whatever.
Usually.
Yeah, usually. It took 12 seconds because I have too much of my profile, I guess. I should have started with a no profile. I might actually do that real quick. Let's start with a no profile, please, because I just wanted to look how it's supposed to look. Okay, so there you go. We got this, right? All the regular numbers work, sure. All the numbers work fine. So, then if I do... we get an imaginary number with really complex parts. So actually that turned out a lot better than I initially expected when I was first considering this idea. It turns out that if you add any real and imaginary number together in .NET Core, the addition operator for the complex numbers just knows you're going to want a complex number out the other end. So it just goes, okay, this is automatically going to be a complex, but it's going to take that as like the real because it's a real number or whatever. And yeah, you can do stuff like this, and you can just go ahead and like basically, oh, I'm sorry, what did I do there? And just like treat it as you would as if you were just like writing this out on paper. And it just works, surprisingly. I was very surprised at how well that worked first time I tried it, but yeah, real numbers are pretty, like, I don't know if you'd really use them, honestly. I've used them exactly once in PowerShell. Exactly once. For that word cloud thing that I made, because it's very handy for translating X and Y coordinates to and from radial, like angle and distance, which was very good for like creating like a circular scanning function. But beyond that, I don't know if you'd really use it, so it probably won't get into PowerShell itself. But it's fun to see you can just like put weird stuff together like this, you know? I don't know. I had fun. But yeah, I think that's pretty much all I could really cover, unless we wanted to dive into the parser, which would be messy, I'm sure. Oh boy. It looks...
7,500, isn't it?
Yep, 7,500 lines. It's a big script. Big block of code. There's even stuff for, you know, if you're in debug build, or if you're, I think there might even be some platform-specific stuff in here, maybe? Yeah, if you're on core, we put this one in. All sorts of stuff. It's a little crazy, but yeah, like it works really well. And if you ever wanted to actually, you know, parse like a new kind of operator or a new keyword. What are we thinking there? Yeah, I guess keyword's the right word. You would probably have to dig into the parser a bit and see where they're already here. But you'll notice there's things that like return expression AST and stuff like that, and that's your very basic expression, which can be a lot of different things actually. It's like, that's like a parent class. If you look at the actual like definition, the AST is 90% comments, the AST file, and I'm not gonna lie, there's so many comments there, it's incredible. Which is great for when you actually need to look at it. But unless you do, you're not going to want to read through it. It is very painful to actually like... It's not something you could read top to bottom. There's so many helper functions it's incredible to read through that and just be like, this jumps to here, this jumps to here, this jumps to here, back to here, back to here. Oh my, what is happening? Like, it, unless you have a specific thing you're following, you probably don't want to go in there. It's just too difficult to follow unless you like have something specific you're trying to follow along and like make work. In which case, go for it. But yeah, otherwise it's crazy. But yeah, between the parser and the tokenizer is really what tokenizer gets you tokens. Parser actually looks through that list of tokens and goes, this is what this means here, here, and here, and this is like what it would translate to in the AST and how you would work with it as the actual code. But yeah, I think that's about all I can really cover without going on for the next 8 hours. So do you have any like questions or anything you want me to like expand upon specifically?
To be honest, I've actually kind of learned a fair bit kind of offhand. So I'm actually, I didn't even know that you could use a dot.
I know, right? I was like, really?
I had no clue.
Oh my god, it's so weird though. I was like, why would you allow that? But okay. Oh my god, yeah.
It's often like I look up the PowerShell window and I'll try something out that you've shown us. I can't believe that actually works. So.
Yeah, it's true. It's very true. Some things are like, wow, did that actually happen?
No, I do. Okay, I do want you to go through the parser, but like I don't have 8 hours to spare.
Fair.
That's the end.
I would also need to bring in some help for that one because I haven't been in there heavily myself. I'd probably want like Patrick or someone to do that one with us because he's definitely had a lot of experience there. He's done a lot of fun stuff in there. Yeah, that's seemingly science on GitHub. He does a lot of stuff, which is good. But yeah, definitely would be game for to have a look. But I don't know if I could explain a lot of it till I've read through it at least 6 times. So.
Also, I think it's a sign that the fire alarm behind me is going off. So that's the.
Oh no.
Yeah.
You gonna be okay?
It's